Frank, what was the biggest problem for you in this riddle?
Uh, well, again, text understanding.
Good morning. We are the guys from Germany. Good morning, Achim.
Good morning, Thomas. Good morning, Frank.
Good morning, Achim. Hello, Thomas.
Hello, Frank. So, 1 minute 20 left. Are you well prepared, guys?
I hope so.
I think I'm well prepared, yes.
Good. Then jump to the start. So 5 seconds left. 4, 3, 2, 1, go. Hill climbing algorithm.
You must divide for a height map of the surrounding area. Your puzzle input. The height map shows the local area from above broken into a grid. The elevation of each square is given by a single lowercase letter, where A is the lowest and so on up to the highest elevation Z. Also included are marks for your current position S, the location that you should get the best signal E. Your current position S has elevation A, has elevation Z. Like to reach E, but to save energy, you should do it in as few steps as possible. During each step, you can move exactly 1 square up, down, left, or right to avoid needing to get... Climbing gear, the elevation of the destination square can be at most 1 higher than the elevation of your current square. Okay. Yes. That is a lot of mountain.
Yeah. Okay, what did we understand?
What I have understand is that starting from S, which has height A, we need to go to Z, which has height Z. And we can only walk up, down, left, and right. So to reach this, we probably would need to go to here and previously to there. So we need to walk around these axes. Something like that.
You can go in all 4 directions, but only to positions which is 1 higher than the previous position. At most 1 higher. So same height or 1 higher or down. But you can't go up when it's too steep up. So that's all.
Because you have no climbing set.
Yeah. So it's a dynamic programming. We need to create a 2-dimensional array and check for every position how many steps we need to come there, the minimum number of steps, and then the minimum number of steps for the last position is the answer.
So a little navigation algorithm.
Yes.
So it's a DFS, depth first search, with the memorization. But okay, that's implemented. What is this?
Some information for us?
I got an algorithm that should work but gives the wrong result, and I don't get it why, so I just try to understand how the movement works. So, but it's more or less trivial. It's go to the next higher level if possible. So if the current level plus 1 is smaller or equal to the next level, then we can go that step. So then it's simply check all the positions. And for each position, find the minimum number of steps. So it's 1 step more than the previous position and so on. It's fairly straightforward, but I get a wrong result and I don't get it why. So I need to draw this map with this arrows like in the example. So maybe then I can see it. But this is, this is not nice.
Do you got a recursive algorithm to found a solution?
I got in BFS, it's a breadth first search in this case. So we have a queue and we put a position on the queue and then we pop the positions from the queue, and for each such a position we check all 4 directions. And if such a direction gives a better result than we have seen before, then we can reach that position in a new minimum number of steps and we store this position. So this is the memorization. And then whenever we find such a position, we put this position on the queue and try on the next round. So this in the end gives for all positions the minimum number of steps we can reach it. It's called a breadth first search. If you never did it, you probably need to read about it. AFS.
Okay.
Get it.
Oh, congratulations. Achim, what about you?
Well, I'm still working on it. I'm not so fast this morning, sorry.
We can enter only from a Z. Is it that? Thanks a lot. This is what I think about stupid in this puzzle. So
I think you could enter from a Y as well, but you can only walk.
now the E mark can be entered
Horizontal and vertical, not diagonal.
Yeah, okay, but Y from an Y? So the E counts as a Z, or what is it?
The E counts as Z, yes.
E has the elevation Z, okay. Okay.
Not wizard then. To add.
My last navigation algorithm was in the study. It's a long time ago.
Still.
Okay, my algorithm is running right now. But probably I'm wasting too much computing power.
Okay.
As always. On these things. And with the example input, I get one step too many. I need to be off camera for a minute or so. And I'm back.
Very fast minute. Wow. You are Flash.
Maybe I shouldn't allow my algorithm to go down again. Put that in, but maybe...
But it can be kind of a spiral, so like in the example. So you need all 4 directions at each
No,
step.
I don't mean that.
Okay.
Considering the z-axis. Because here I allow it to go down one step. Maybe I should drop that to limit the number of possible paths. That is only same height or higher.
Yeah. That's right.
Frank, do you working on the second part?
I don't get it how this works with this E in the middle. So I substituted the E within set, and it does still not work for some reason. And I don't get it why. I got some bug in my code, and I don't find it.
I'm running out of options in that case. That's not good. Am I running out of possible paths?
So my program is running.
Now my code works for the example, but not for the real input.
Yeah. This is strange.
So there's maybe one other obstacle in the statement text we need to consider. Okay. In the real example, the start point is not the upper left corner. It's somewhere in the grid. I always starting from 0, 0, but it's not correct.
Okay.
I am actually scanning for start and end position.
Yeah, now I will do this too, then it will work.
But my algorithm just dies somewhere out in the wild. X factor Y.
Okay, then it works. Now I got a star.
Yeah, congratulations
Maybe I can
again.
explain later how it works for me.
On which level is S, the start point? Has the elevation A. Okay, thank you.
Okay, second star was not too hard today too.
So you were finished?
Yeah, I have to admit defeat because I have no idea where my algorithm goes wrong.
Okay. Then,
Thomas,
Frank?
are you still with us?
Frank, can you explain your solution for the audience?
Yes, he's not.
His microphone is closed.
Oh, sorry.
You're muted.
Yeah, okay. Frank, congratulations. Can you explain your solution for the audience?
Yeah, I would share my screen, yeah?
Yes, of course.
Yeah.
And maybe we can mute Achim, or Achim, do you want to make some hints?
So, the point is, this is a more or less standard dynamic programming problem. So what we do here, we make us a memorization, and we try to find for each position in this grid, which is the minimum number of steps possible to get there.
Yeah.
And once we got the minimum number for one position, we can check all 4 surrounding positions and also get a minimum number there by adding 1. So we start here at the first position, and then we put this position on a queue, and then we do a while loop over this queue, and we pop the first position, and we check all surrounding position. And whenever we find such a surrounding position which was not visited before, then we put it also on the queue and also mark it as number of steps. So here we got a 0, and so we get here a 1, and then if we check this position, we get here a 2 and here a 3 and so on.
Okay.
And when we do this until the queue is empty, then somewhere we visited all positions, and then we can simply output the answer. And in the code, this looks kind of like this here. So here I'm parsing the input.
Yeah.
This is the number of lines and the number of columns. So here I'm marking my start and end position. So the end is marked with a Z and the start is marked with an A. And I kind of memorize myself where's end, where is start.
You replace the S with an A?
Yeah.
Okay.
S with an A and end with a Z,
yes.
Because it's in the statement text somehow. Yeah. So, and then the real algorithm starts for the path searching, the BFS. So I call this variable here dp. This is the dynamic programming. So this is a two-dimensional array which holds the minimum number of steps to get to this position.
Yeah.
So I initialize all position with infinity, because I know with infinity is kind of unreachable.
Okay.
So, and it's a very high number. So I initialize it to 1,000,000 or something. So then I initialize my first starting position with a value of 0. So 0 steps to start at the first position. Yeah?
Yes.
Okay, then I create a queue and place this first position onto the queue. So this queue now holds one element, the starting position.
Yeah.
So here I got some definitions for my 4 directions that I can step. So, and then I do this while loop, while q.size. I take the first element from the queue.
Again.
Here,
what is it? What is the while loop? Q size?
So
what does this
while
mean?
there's some elements on my queue.
Okay.
So
okay.
So I put first one element on the queue and then I loop until the queue is empty.
Okay.
So here I pop the first element from the queue. Here it's the first element removed. And this now holds the starting position because this was the only thing. So E is 0 and J is 0. So, and then I iterate over my 4 directions. So I check all 4 surrounding fields from my current field. So this is the formula to get the position of this currently checked field. This is the current field plus this vector, so -1 and so on.
Yeah.
So IIJJ holds now the to check position. So now this if checks if we currently can do the step. So if I'm not out of the grid, this is these 4 things, so bigger than 0 and smaller than n and so on. And this is the important one, if the current value for the current DP value for the new field is bigger than the current DP value for the old field +1. So this is, if I check this A here, if this value is bigger than 0 + 1, then I want to really step into this field. So then I check if I can step from the rules of the text. So if this elevation is correctly, the elevation, so the highness of the field, and if this is also possible to step into this field. So then I know I never was at this DP IIJJ. So I put a number in this DP IIJJ, and it's the number of the previous steps +1, because I did 1 step.
Yes.
So then I put this new position onto the queue, and then everything is right. So, and then at some position I reach the end position, and once I reach the end position here, I know this was the shortest path. So yeah, it's fairly straightforward.
But why this is the shortest and not the second shortest?
Because I'm always do all steps from each position. This is, so if I, for example, am here in 1, 2, 3 steps, so it is not possible on this queue to put ever a bigger number before the other number.
Yeah.
You always put on the queue, here you got this queue.mplace, this IIJJ is always, no, this DP value is always +1. This means whenever I enter any value into my DP array, it's always the shortest possible step to go there.
Okay.
So yeah, and that's it. So then the second part of the puzzle is more or less likewise, except we have not a single starting point, but we have to find the shortest path from any A position to the end position. So we have multiple starting points. So what I changed then in my code is not too complicated. This is only that I put all these A's I find in the grid onto my queue in the first place. So I define it here above. Now I iterate all the grid, and whenever I find the start marker or an A, then I put this position onto the queue. This means the first time my while loop starts, there's not only one position on the queue, but some of them, like 10 or 100. And always, and everything else runs exactly the same. So the while loop didn't change at all. So the BFS algorithm.
Yeah, very cool, Frank. Frank, what was the biggest problem for you in this riddle?
Well, again, text understanding. So the first thing was this E counts as in Z. I didn't notice it. I thought E can be entered at any time for some reason. And I needed, I don't know how much minutes to notice that. And then the second thing, what was this? There was something else, which was also, I can't remember what was it. I would have to look the video. But well, understanding the text, yeah.
Okay, I understand. Then, thank you guys. Achim, are you there? You are muted. So,
I'm muted.
we are lesser than an hour solved this riddle. Also, we is Frank solves this riddle again, and congratulations. And we see us tomorrow again, next day at 6 o'clock.
So, have a nice day.
Have a nice day.
Have a nice day.
Bye bye.